Hello and welcome to the AVID Technology Podcast with me, Ryan Morn. We've got a really exciting podcast for you today, and I know I always say that, but today is really exciting and it's a bit different. I've been looking forward to doing this for a long time. We got the opportunity to talk to Eva Hakansson. She has got an absolute passion for vehicle electrification, and she's somewhat famous for being the pilot and the builder and the engineer behind the world's fastest electric motorcycle. So without further ado, we'll get into today's podcast. So I'm here with Eva Hakansson, and really excited to be doing this podcast today, Eva. So thanks very much for joining us. Could you just tell everyone about yourself and where you're from?
Well, thank you for having me. And to tell you where I'm from is not that straightforward. Okay. So I'm originally from Sweden. I moved to Colorado in the U.S. About 12 years ago for love.
Okay.
And moved to New Zealand about a year ago for work. And brought my love with me. So we're both here. Still married to the same guy. So I'm currently in New Zealand.
Okay.
So I guess that's where I'm from right now.
Okay. What did you do when you were in Colorado?
So I got my engineering degree in Colorado and went all the way through it for a PhD in engineering, mechanical engineering. So that took quite a few years.
Okay. Yeah.
And of course, when you are in engineering school, you need a solid hobby project because you have so much time and money to spare. You know?
Yeah.
Yeah, you basically have no life, but you can always squeeze in an hour of work between math homework and physics assignment, and if you do that every day for 10 years, you can end up with the world's fastest electric motorcycle in your garage. That's basically what I did. Spent most of my time in Colorado building an electric vehicle to be the fastest in the world.
Awesome, and of course. The motorbike, for everyone who maybe hasn't seen it, I know a lot of people have, it has a name, doesn't it? It's a pretty cool thing.
Of course it has a name. All purpose-built, unique racing vehicles needs an identity. So this is Killajoule, is its name. So it's a big red, it is under international competition rules, it's considered a motorcycle. Okay. And because it has fewer than 4 wheels, and that's the definition of a motorcycle. It has 3 wheels, but it's not symmetric. It's a sidecar streamliner motorcycle.
Right. Okay.
So it looks basically like a red rocket with one wing sticking out on the side, and that wing has a wheel on the end.
And I mean, it's incredibly fast. This thing. How fast has Killajoule been?
It has been 270.224 miles per hour. So that's about 434 kilometers per hour. Wow. So it makes it the world's fastest electric motorcycle, but it makes it far from the world's fastest motorcycle overall. Right. And I need to change that, of course.
Okay. What's the fastest motorcycle then?
The fastest motorcycle is at 376 miles per hour, or about 605 kilometers per hour.
Okay. So you've got a little bit of making up to do.
I do have a little bit of making up, about 100 miles per hour. So, and if you know anything about power, you know to increase about 1/3 in speed takes you somewhere about 2.5 times the power.
Yeah, and that's even with the really good aero effects of, because it's very slippery. The aero of it's very
yeah, it's decent. It's completely streamlined. It looks pretty much like an airplane with one tiny wing.
Yeah.
But there's more work that can be done on aero. Okay. It's not as good as the best ones, but much better than the normal motorcycle, of course.
And you're not. Do you kind of you don't sit in a normal kind of motorbike riding position? Is it? Are you?
Not at all. So nothing is normal with this motorcycle. So it has as much in common with a normal motorcycle as a Formula One car has in common with your family van.
Okay,
they're both considered cars. These are both considered motorcycles, but it's totally purpose-built. Right. And philosophically, it's more than like a car. You sit inside, it has a complete roll cage, it's fully enclosed. You pretty much laid back like in a recliner seat. The 7-point harness, helmet, flame suit, every safety equipment known to man.
Wow. So what, 10 years ago, when you started this project, I mean, this is kind of for an electric vehicle, that's a long time ago. I mean, everyone, obviously, electric vehicles now are super cool, and everyone gets it, or people are starting to get it in the new world, the post-Tesla age. But back then, what inspired you? What were you thinking? Like,
so I've been in electric vehicles since long before it was cool. And my husband, Bill Dubay, has been in electric vehicles even longer. He built his first conversion in 1995 and has commuted with an electric car since 1995.
wow.
I got into electric motorcycles about early 2000-ish, 2005 or so. Actually, first time around, I went to college. I went for a business degree, focusing on sustainable business and economy, and realized basically from a thermodynamical perspective, the electric vehicle is unbeatable. There's just nothing that uses energy more efficient. This was on the big boom of ethanol, and biofuels was the hottest thing.
Yep.
But I just looked at from the scientific perspective and concluded that everything except electric vehicles are incredibly wasteful.
Yeah.
And why should we just throw away 80% of our energy or 90% of our energy to get to work and back?
Yep.
So I just kind of got involved in electric vehicles. My dad has actually been in electric vehicles since the 80s. No, sorry, since the 70s.
Oh wow!
Since
okay.
the first oil crisis, whenever that was, 1970 something. He built an electric scooter prototype for Monarch. He worked for Monarch with their racing motorcycles.
Oh wow!
But unfortunately, the same day the motorcycle was presented to the press, the oil crisis was over.
Right.
So it was kind of the bad timing. So that died again. So he just kind of continued on this as a hobby, did some electrothon and things in the 80s. Went to the UK, actually, competing. Lucas Oil Electrothon, I think.
Right, yeah.
1980 something. I was there. Not quite in a baby carrier, but probably in a stroller.
Yeah.
So my dad has been in electric vehicles forever. So I kind of got it as a genetic disorder from that side as well. My dad is also a motorcycle racer, so it's double genetic disorder.
Yeah, yeah. Okay.
So it was just the electric vehicles, it's just everything's kind of perfectly coming together. When you have everything you want from a vehicle, you have power, torque, speed. And from a sustainability perspective, it's incredibly efficient, and it's a good way of using your electricity. And then you have the zero pollution where you drive it, and it's just like you're looking at the whole perspective and the way we use cars in our daily lives. Like I commute back and forth about 30 minutes each direction.
Yeah.
An electric car is just a no-brainer.
Yeah.
I bought a used Nissan Leaf, a direct import from Japan. It's the best car I've ever had, and it cost me pennies to drive.
Yeah. So from the outset, did you always think, right, this is going to be the fastest electric bike on the planet, or did it kind of start as I'll build an electric motorbike, and then it go, I'll make a bit of a fast one, and then a bit faster, and then a bit? Did it snowball, or was it always going to be the big red Killajoule right from the start?
The Killajoule was always built to be the fastest,
right?
But it wasn't the first one. So how I really got into electric vehicles were back. Well, I finished my first university degree. I wanted an electric car, but I couldn't afford one.
Yeah.
And I didn't have the garage space to build one. And my dad suggested that, well, why don't we convert a motorcycle to electric? That will be a nice sized project for you. And I had just gotten my motorcycle license, so I was all set for that. So we converted an old Cagiva Freccia, a weird Italian two-stroke motorcycle.
Yeah.
We bought with a seized engine block, and took us about, I don't know, half a year or so. Some Thunder Sky batteries in there, and a E-Tech electric motor, the standard setup for that time.
Yeah, wow. Yeah.
And we built it together in Sweden, and that really got me into electric vehicles. And then around the same time, I wrote a book about electric vehicles. In college, I kind of got recruited by a green lobbyist organization.
Right. Okay.
A green motorsport organization, and they wanted me to write a book about electric vehicles because no one really knew anything.
Okay. So
I wrote in Swedish, a little tiny, like 100 pages, popular scientific books explaining what is an electric vehicle, what is a hybrid vehicle.
Right.
And of course, I wanted a picture of the fastest electric motorcycle at the time, which was the Killajoule.
Right.
The drag bike Killajoule. So I decided I would track down the owner and ask for permission because I'm a rule follower. So every picture that was published in this book, of course, had written permission to be used.
Yep.
So I tracked down the owner, built a base, sent him an email, say, hey, can I use a picture of your motorcycle in my book? And he said, yeah, sure. And then 3 more pages of email came back about everything about the Killajoule. And then we were just kind of communicating back and forth. And turned out that we were planning to go to the same electric vehicle symposium, the EVS 23 in Los Angeles in 2007. And that's where we met in person, and the rest is just history. So a year later, I moved to Colorado, and about a year after that, we got married, and we're still married. so that's kind of, we started with this conversion, the Electrocat I built with my dad.
Yeah.
And then I married Bill and kind of got the Killajoule in the deal.
Yeah.
And we were drag racing the Killajoule. And so the Killajoule is a 650 horsepower electric drag bike, purpose-built for drag racing. And it does 0 to 60 miles per hour in less than 1 second. It's a 3G acceleration.
Wow. Okay.
But the problem with running on the drag strip is that you run out of room. It's only a quarter mile, 402 meters.
Yeah, yeah.
So it's really, really hard to get to top speed.
Yeah.
So at the 174 miles per hour top speed, that was at the time the fastest electric motorcycle in the world. But that doesn't really impress people.
Right. Yeah.
that just
depends who you're talking to, I think.
Yeah, I mean, in drag racing circles, that's respectable.
Yeah.
But the general public, they were kind of, oh, okay, well, I can go to the motorcycle dealer and buy a motorcycle that goes that fast.
Yeah.
And you can. So we were drag racing the Killajoule, and the whole mission, both for Bill and for me, were to promote electric vehicles. And when the acceleration, it's impressive, but we realized what people care about is top speed. That is really what gets the message through how superior electric vehicles are.
Right.
So we just kind of decided one day, the Killajoule was kind of getting due for retirement. It's been racing for almost 10 years at the time. And so we thought, why don't we build the world's fastest electric motorcycle? Basically, it was just a decision.
As you do.
Or it wasn't really, it was a 2-step decision. Let's build something that's insanely fast.
Yeah.
And we decided to stick to motorcycles because we would get more speed for the money. It's simply a smaller vehicle, and with the horsepower is what's the big expense. And with a smaller vehicle, you can get more speed out of the same horsepower. Also, you can have a smaller trailer, and everything just gets easier.
Yeah, yeah.
But to go really fast, you have to have a streamliner motorcycle. That's really the only way to get to any significant speed. And the goal was 400 miles per hour.
Right.
That was the initial goal. It's still the goal. Still the goal.
Yeah.
I'm still working towards that. So yeah, that's kind of the whole story. We just decided one day, hey, why don't we do this?
So you must
we thought
you've got to be the only couple who got married as a result of EVS. That's.
I guess that's we're the only couple that ever got married thanks to EVS. Yeah. Yeah, I think that's kind of unique.
Yeah, romantic date at EVS, and then
it's not. I wouldn't recommend it for your matchmaking needs.
It's definitely a niche. Definitely a very special niche. Yeah.
Yeah. What do they say? The odds are good, but the goods are on. Or
I was, you can't expect to deal with, very intelligent people and have normal behavior. That's what I always tell myself.
Yeah. You find a lot of intelligent people at EVS, but they're definitely quite quirky. But yes, that was I had never thought of it that way. I had a date at EVS 23,
and particularly back then. I mean, because it is now. It's more mainstream, and people. You guys were really before your time. It's
absolutely.
Completely. Because like now, everyone is talking about electric racing and electric motorsport, and it's a big topic. Like people are, they're launching whole championships, and you've got the Formula E, and it's a really mainstream thing. But back then, it was so. I can't imagine many people would have even thought of that, let alone sort of thought of it and then started to execute on it and actually get on and do it. It's that's phenomenal. So,
well, it takes 10 years to become an overnight success.
Yeah.
That's really the reality.
Yeah.
No, I've always known that electric cars would take off. I have always been convinced. Everybody says that when you write on something, but I've always been convinced, and the development has actually gone quicker than I think most people expected. The start was a little bit slow. I thought 2010 would be the big breakthrough year. Didn't happen.
Yeah.
It was a few years later, but now it's here in New Zealand. The number of electric vehicles, cars, passenger cars have doubled in less than a year.
Yeah.
When I bought mine about 13 months ago, there were 6,000 electric cars for 4.5 million people. And now there are 12,000 electric cars, and they think it will double again this year.
There's a lot of really good product coming into the market that's affordable and people can get, and they're just understood so much better now, aren't they? It's it has taken a little while, but now you do find that once someone's driven an electric car, they generally don't want to go back.
It's a bit when the iPhones were released. There was kind of, that's weird. A big phone with a glass front. Who wants that?
No keyboard. Yeah.
No keyboard. That will never sell.
Yeah.
And then 2 years later, it just exploded, and now it's kind of, you don't have an iPhone? Weird, or at least a smartphone.
Yeah. Definitely. Yeah. So you then spent in Colorado. You spent was it 8 years building the bike, and then you started doing runs?
Yeah, we cut the first steel tubes physically spring break 2010.
Right.
And then raced it 18 months or a year later.
So Bill is breaking in here and saying, we actually raced it the first time 6 months later.
Oh, wow.
We took it to Bonneville the 6 months after we started build. It ran, but it didn't complete the run. So we built it with 2 wheels as a solo motorcycle because I didn't even know such a thing as a Streamliner sidecar motorcycle existed. Okay. So we it was another crazy thing in the project was we decided to build a land speed racing vehicles without ever having been to Bonneville.
Okay.
So we just searched for Streamliner motorcycles online and downloaded all the photos we could find. And then we looked at what other people had done, and then we copied the pieces we liked.
Right. And you did do, so this wasn't like a checkbook exercise where you went out and you got some shop to do it. You guys, I've seen some of the photographs. You really did it, like all of it.
Oh yeah, we joke we would be on a shoestring budget if we could afford shoestrings. Yeah. And we were, I don't know how we were so naive. I don't know if we were so naive. I think we were in denial how much this was going to cost because we somehow had thought it would be maybe at $10,000 in parts or so.
Right.
And we have spent 10 or 20 or 30 times that. I don't know. I never kept count.
Yeah.
I just know that the paycheck and the credit card bill had about the same numbers every month for quite a few years.
Oh dear. Yeah. Yeah, there is. I think even electric. Even electric motorsport suffers from. You need a lot of money to do it.
Oh, electric motorsport is not cheap.
No. Yeah.
It's an addiction. It's very much an addiction. And it's the only way to explain it. Actually, I tell people a drug addiction would have been cheaper, but the high is not as sustainable.
Yeah.
And this motorsport keeps you out of trouble because you simply don't have any money to get in trouble.
Yeah. But then...
or time.
You really helped because you guys have... you've got some real skills, you and Bill. Sort of all the kind of design of the bike, the fabrication of the parts, all the kind of build.
So we have done. So design wise, we're probably about 50-50 in the split, and then we have a few other people that help me, including my dad. Manufacturing wise, I have probably spent 80% of the hours.
Yeah.
Blood, sweat, and tears. And so combined, me and Bill, we've probably done 95 to 99% of the work on the bike. in our garage in our spare time. And then we have had people helping, very valuable people helping, but not as much as time-wise.
Wow.
But yeah, we're both mechanical engineers. And I got my a PhD in mechanical engineering. Bill has a bachelor degree in mechanical engineering and a PhD in applied physics. So
right, and you can weld.
So engineering is our addiction in more than one aspect.
Yeah, and so you did quite a quick build and ran it in 6 months. But then how long did it take to get to doing the proper the record attempt?
So we did set the first world record after 18 months.
Yeah.
It was quite modest. It was 138 miles per hour, but at the time that was the official world record for electric motorcycles.
Oh wow! Okay.
And then shortly thereafter, we installed a new powertrain. So we started out. We actually cannibalized the Killacycle for its old DC powertrain.
Right.
With two advanced DC, basically forklift motors and Zilla controllers and the A123 systems battery pack.
Yeah.
And that race, when I came to 138 miles per hour, I used up 4 motors that I just arced and burned up. We think they inhaled salt. They were open frame, air cooled motors, and they just couldn't take the environment.
Right. Yeah.
So that was we realized we had to go AC.
Yeah.
And that's kind of where the stories meet with you guys and the Evo motor.
Yeah.
So we got an Evo motor in 2011, the AFM 240, installed that with 2 Reinhardt controllers and A123 batteries again, and it has run flawlessly for 8 years.
Right.
And yeah, I don't want to show it in any photos because it's been in such harsh environment. It's quite corroded.
It's a bit chewed up.
It is not pretty anymore. It's a bit chewed up.
Yeah.
I tried to get a photo of its placard, and it has lived a hard life. It's definitely not a show condition anymore. But it has just run. It has just run and run and run with zero problems.
And is it?
We are just blown away, and I'm not just saying that because I'm talking to you. I'm saying that to everybody that's asking. It's an absolutely amazing motor, and that's really what the reason for our success is the reliable powertrain.
Right.
Because the other teams spend their whole race week just trying to get it to run, and then they spend all winter on the dyno trying to get all cylinders to fire and timing to work, and then they get out and solve these things still don't work.
Yeah.
And we just plopped this in. We were out to Bonneville maybe 3 weeks after we had received the motor.
Yep.
We just stuffed it in, wired it up, took it out. That event rained out. So it took another year before we could set a record with the motor.
And how
amazing.
Does it drive? How does it work? Is it rear wheel drive? You have a single motor, right? So one motor driving through a chain to the rear wheel? Yeah,
so it's a motorcycle. Sidecar motorcycles are only allowed to be driven on the rear wheel.
Right.
So it's a one-wheel driven, 3-wheeled vehicle. So just to give it a bit of it, the motorcycle, the fuselage body has a front wheel that steers and a rear wheel that drives, and that is enclosed in something that looks almost like an airplane body.
Yeah. Okay.
And then on the side it has a sidecar which looks like a wing, which actually is an upside down wing.
Oh,
and it has a skinny little wheel on the end of it.
Okay, to give you a bit of stability.
Yeah, and the sidecar provides downforce.
Okay, yeah, keeps you on the ground. You want that, so you're not taking off. Where are the batteries? Do they sit under you or next to you? Or?
No, they sit behind me. So everything is stacked. Yeah, so it's a front wheel, and then it's me. Then it's a firewall. Then are all the batteries.
Okay. And is it a big battery pack in it? Do you need a lot of batteries, or is it?
It's not that big. It's 10 kilowatt hours, 400 volts.
Okay. Weighs
about 150 kilograms or so altogether with boxes and everything. And then the stacked after that is a fire extinguisher system, which is required because you have to follow the rules for internal combustion vehicles.
Yeah.
And then the motor and on top of the motor are the Reinhardt controllers.
Right.
And then it's a direct chain drive to the rear wheel. So no gearbox, just a reduction gear.
Oh, cool. Okay. So really very simple driveline compared to some of the bikes that have engines and 6-speed transmissions and all that sort of stuff. It's very...
Oh, yeah. It's a giant cordless drill with wheels. It's as simple as it gets.
Yeah. Okay. Yeah.
It's a little bit slightly more. It has so the Evo AFM 240s. It's electrically 2 motors.
Yes.
Two motors on the same shaft. So that gives a little bit more complexity because it has 2 motor controllers and 6 wires going into it. But that's nothing in complexity.
So you're taking advantage of the lower phase currents of running 2 separate controllers rather than a single big controller.
Yeah, some people claim that. I'm not that deep into the electrical engineering to really have an opinion.
Yeah,
I have to say. So I'm a mechanical engineer. I'm really much more on the. I totally understand the electrics but it's not my specialty.
Yeah.
So when you start talking about the nitty gritty of motor controllers, I just nod and say, okay, if you say so. I'm sure it's right. So that's also the kind of the division in the design work is that Bill is more heavy on the electronic side of things. He does the motor setup, programming of controllers and all of that.
Right.
And I prefer cutting and bending tubes and welding and painting. I like painting. That's a weird thing, but I find it very, very soothing to brush paint things.
Did you take? Is Killajoule in New Zealand with you? Did you take it over there? Or?
So Killajoule now lives in New Zealand, but right at this very moment, it's actually just arrived to port in Adelaide, Australia.
Oh, wow.
So it has been on a sea voyage for the last 2 weeks.
Right.
And it arrives perfectly on time because in 2 weeks we're going to Australia and Lake Gardner and the Salt Flats for a new record attempts.
Oh, brilliant. Okay. So what's the plan there?
So there are several parts to the plan. It's a new venue for us, and it's a quite challenging venue. It's 150 kilometers off the sealed road, so it's a very, very long and poor dirt road to get to the event.
Yeah.
Logistics and shipping is a challenge because you have to ship a sea container and have it trucked out to the racetrack and I'm actually it's an adventure just to get there, and you are far out, you way outside mobile phone coverage or anything, and if you didn't bring it, you won't have it. So it's camping in the outbacks and racing at the same time. So just understanding the venue and learning logistics is a big learning experience this year. But the main purpose of the event is to try out new components. So we have a new bike on the drawing board and soon on the shop floor.
Okay.
The tubes are sitting and waiting to be bent and cut.
Okay, and the new bike is called?
Green Envy.
Green Envy. Okay, cool.
So Green Envy is the successor to Killajoule. Killajoule is now, it's 9 years old, and that's very old for a racing vehicle, in particular a racing vehicle that lives in a very corrosive environment.
Yeah.
So it's kind of due for retirement. I get annoyed at all the mistakes we made. That reminds me all the time. The frame isn't perfectly straight, and there are all kinds of things we could have done better. So we're building a whole new bike, but a meter longer, and making room for twice the powertrain.
Right.
So to get to this 400 miles per hour, I need somewhere in the order of magnitude 1,000 horsepower, and to fit that, I need a bigger bike. Also need a bit more sturdy to take that amount of power and torque.
That's a lot of power. A lot of power.
Yeah, it is, but an electric drivetrain, that's not impossible at all. Yep. It's expensive, but and the beauty with electrics is that you can stack such a drivetrain in one long, skinny unit.
Yeah.
So that's another thing with with land speed racing is what determines your horsepower need is how big the hole is in the air, the hole you make in the air. So the skinnier the vehicle is, the faster you can go with the same amount of horsepower. And the internal combustion guys, they struggle with fitting their big engines in a small cross section. And with electrics, it's actually the rider's shoulder width that sets the width of the vehicle. The vehicle could have been skinnier from a powertrain perspective, but I need to fit my shoulders.
Right, okay.
And it ended up being, I think it's about 21 inches wide, and that is my shoulder width. And that sets the overall vehicle width.
Wow, 21 inches. Wow, that's, okay. I didn't think, I wouldn't fit inside that.
Most normal-sized people would not fit. If you have to be 5'2" or 158 centimeters to fit inside. That's what it's built for.
Right.
Yeah, Bill has never been inside it.
You have a strategic advantage.
Oh yeah, absolutely.
Yeah.
So we're building a new bike, the Green Envy. The plan debut is in a year, which is a very optimistic plan considering the fact that I also work a full-time job.
Yeah.
But we're trying out components. So we're trying out systems like data logging, battery management. I have had students designing a new brake chute for me. I'm hoping to be able to try that out. But most importantly,
you must really trust your students.
Well, I know their teacher. They must be good. Yeah, we'll have a backup chute. Yeah, that's a regular design. But the most important thing we are trying out, which is a super exciting project, is that I am literally reinventing the wheel.
Okay, right.
Okay, right. So the weakest link in any wheel-driven vehicle is the tire.
Okay.
So that's you're transmitting all this horsepower through a tiny little contact patch of rubber.
Yeah.
Spinning at 5,000 RPM. And tires is it's just a huge problem. And also at 5,000 RPM, here I would test your physics knowledge here.
Yeah.
If you have a wheel, it's 2 feet in diameter, 24 inches, 600 millimeters, spinning at 5,000 RPM. Yeah. If you were sitting on the surface of this tire, what would be the G-force acting on you?
I can't do that math in my head on a Friday morning.
What do you think? Just take a guess.
20?
Okay, take a guess again.
100?
No, again.
No, go on, tell me.
About 30,000 G.
Oh my God, okay, right.
So a little piece of rubber thread that weighs 1 gram weighs 30 kilograms at speed.
Wow, okay. So holding the tires together is
holding the tires together is a huge issue.
Right.
And the problems with tires, if they break and run flat, is that it will probably send you airborne in a very.
Yeah.
That is the worst case. Best case, it will just tear your vehicle apart.
I have seen some bad accidents with on speed races and drag races with tire blowouts. It's always it's a good way to end up pointing the wrong way up. Yeah,
and also adding to the problem is tires are fairly expensive and hard to come by at these speed ratings.
Yeah.
But even if they had the sufficient checkbook, is that they only come in very specific sizes and they're typically always designed for cars. But they are all designed for cars. So for a motorcycle, you end up with grossly overdimensioned tires because you're running on car tires.
Yeah.
So all of this was not attractive from a building and racing perspective. So we've been dwelling on the idea for years that we've been looking at tires, how tires fail. I had a tire delaminate at 213 miles per hour. The pieces came flying out of the surface and hit the inside of the fender, and smoke came out of the bubbles that bubbled up on the tire. I thought I was on fire, but it was actually the front tire coming apart.
Wow.
But so that was quite exciting. And things like that, we just kind of come to the conclusion, looking at tires, and what happens is that tires appear to fail in the interface where the rubber is connected to the core.
Right.
To the core of the tire. And that's tires are made up of layers that are basically glued together, vulcanized together. So the idea we've been dwelling on, can we make a wheel that still has a rubber grip, but it doesn't rely on adhesion? So it isn't glued together. It's mechanically held together. So over about 2 years working on this, we have designed our own wheel, which is a solid aluminum wheel. It has tons of drilled holes, looks like a spaghetti colander. And then a mat with rubber nubbies sticks through from the inside and then screwed into place with a back plate. So you have a metal wheel that has little hairs, or it looks like you need to shave, like a 2-day beard. It sticks out through this metal wheel, and the rubber touches the ground. So little fingers about 10 millimeters in diameter. This little rubber nubbies sticks out 6 millimeters. Or it looks like Lego pieces.
Right. Okay.
Or something NASA would make for the Mars rover. Looks very, very odd. But the idea is that this is a tire that cannot run flat. And it still has the rubber grip.
Yeah.
So that was a long description. But that's what I've been working on over the past year at the University of Auckland.
And is it, have you tested that without being in the driving seat, so to speak, already? It's like...
No, I have not.
Okay.
I haven't had that luxury. I basically run out of time.
Okay.
So we just packed it up, shipped it off to Australia.
Right.
Well, actually, I say it isn't totally true. We did try a prototype wheel in 2017. So the wheels I'm trying out now in Australia are super fancy. They're machined by the Central University machine shop.
Right.
Machined out of a billet. They're absolutely gorgeous. Has taken enormous amount of work to make, but the technicians made them for me. But in 2017, Bill and I built a prototype wheel for the sidecar. Same idea with 3D printed little rubber fingers.
Yeah.
That we just a friend machined the main wheel in his garage in his spare time, and we drilled all the holes by hand. 3D printed the rubber inserts, and we tried that in 2017. So that was, I think, that prototype wheel was convinced the university to give me a small research grant to continue on it.
Okay, so you it's going to be a big event then. Really, lots of excitement, a little bit of lots of data gathering, and I guess that's massive. So a completely new wheel system for the...
Yeah, so it's really a test session. I would love to set some new records.
Yeah.
If I can manage to break the light twice, it would be an Australian record, because I'm running in class that's open.
Right.
For record wise, I'm always hoping for 300 miles per hour. I think the bike has 300 miles per hour in it if everything works out perfectly. But that's not really the main goal. The main goal is to try out all these new stuff. Yeah. Because if it works, then we can just throw that onto Green Envy and go racing with some serious horsepower.
Wow, fantastic.
So that's a long plan and long explanation.
There's one last thing that I wanted to ask you about, because we're sort of the time's just absolutely flown by. But you're really passionate about science and engineering. Obviously, you can just tell that talking to you now. But you do a part of what you're doing here is to try and sort of show kids and particularly young women the opportunities that are available in science and engineering. Can you just sort of tell me a bit more about what you've been doing there as well? So,
I've always loved science and engineering. It is clearly a total addiction. The whole STEM field has such great opportunities for jobs. I mean, they're well-paid jobs, flexible jobs, challenging jobs, satisfying jobs, and somehow we have convinced half the population that they can't do these awesome things just because they're girls, which is just sad, because two things happen. We are losing out on talent. We're losing out half the talent base. This may be the inventor of the next great battery or the cure for cancer, or who knows what, that we're missing out.
Yeah.
And we're missing out from an equality perspective. And I just it just upsets me because I have had these great opportunities in my life, and I want everybody to realize that being in STEM, the only thing that really matters is your brain and your hard work and your skills.
Yeah.
And nothing really matters, and we shouldn't sort people just kind of prematurely that you're a girl, you can't be in STEM. And actually, if you're a race car driver, it's great to be small, but it's a whole different story. So yeah, I'm trying to change the image of engineering to show that mechanical engineers don't work on oily engines or repair your washing machine.
Yeah.
We actually work on the absolutely coolest projects in the world.
Yeah.
And it has really nothing to do with the greasiness or macho-ness too. So I do that in all kinds of ways. I try to visit schools when I can, when I have time. I do also show that engineering is used for very girly things if you want to.
Yep.
So I have a 3D printed handbag.
Right, okay, yeah.
And as soon as I find a few minutes to upload it to my website, you will be able to download it and print your one for yourself. But I've CAD'd it myself. I teach CAD at the University of Auckland, drafting and CAD. So I've CAD'd my own handbag. It's 3D printed, has compartments for like pens and iPads and everything, and it has built-in LED lights so I can find my stuff.
Awesome.
And it's funny. I meet people to talk about electric racing, and the only thing they remember is my handbag.
Okay,
but that's great. I'm perfectly fine with that. But that's part of trying to give mechanical engineering a new image.
Yeah, it's fantastic. I really, we're going to unfortunately we've run out of time, but I'm just, you are such an inspiration, Eva. I'm really privileged to have been able to talk to you, and it's fantastic to see what you're doing. It really, really is. So all the best in Adelaide, and really, really excited to hear more about Green Envy and how the plans for that are going. So, well,
we will keep it. Everything we do is public, so I'm an open book. I try to publish everything I can about wheel development and racing. And we don't have many secrets because I don't really see a point in keeping secrets. Okay. It's easy for me to say because we're so way ahead of the competition.
Yeah.
So it's easy to be open and a bit cocky. But for right now, we are far enough ahead of the competition that I'm happy to tell all the secrets we have for racing.
Oh, it's fantastic. Brilliant. So we'll put in the show notes, we'll put links to your website so people can find you and follow you there and keep up to date with what you're doing. But that's been brilliant. Thank you. Thanks very much, Eva.
Well, it's been a pleasure to be on the show.
Thank you. So I really hope you enjoyed today's podcast. To be honest, we could have kept going for hours and hours and hours, but we had to stop. We just ran out of time. So it was wonderful to get the chance to talk to Eva and find out more about the Killajoule and her new project, the Green Envy. There's a link in the show notes below. So follow Eva, keep in touch with what she's doing. It's really exciting. She's doing an absolutely fantastic job. As always, really appreciate it if you could leave us a rating or hit like, comments, or if you've got any questions or anything in particular that you'd like us to look at, please feel free to get in touch and send those in to us. Okay, that's all we've got time for today. Thanks very much for listening, and we'll look forward to talking to you again soon.